Tell Sam.
You should say,
I bet you it's not.
Okay, it is filming.
hey Sam, it snowed yesterday and it stuck to the ground for a little bit.
It
Then
really
Like 2
didn't.
seconds.
It was mud.
Really not at all
Sam.
sticking to the ground.
it
It was
kind
like
of,
4 feet.
yeah, it was 4 feet of
It
snow.
melted
4 feet, 7
all
inches.
this morning
And
though.
we made a snowman that was in the shape of
Oh, a
Barney
panda.
and
Can I
did
see
that
the panda?
Before.
a pink. Oh,
Panda.
Okay, have we
Or
seen the
tiger.
panda the entire
I
time?
like reading books.
wait, where's Nick?
I don't know, but
Yeah, attacked by a
told me
panda.
last week he wasn't going to be here.
Yes, he did say that.
Who do you think's not going to be here next week?
Me.
Me.
We've been
Actually,
losing one person a week for the last.
no, I'll be here.
It might be me.
It's the
I'm
final
missing a week in
destination.
March.
Your
Okay.
thumb's gonna fall off.
Like
in the
March
air.
5th or 4th or 5th or 6th or something.
No,
If
or
it's a big
7th or
level, get
8th
it
or
done.
9th or 10th.
Okay,
On the week.
so momentum. We have none at the moment. Let's go.
I like momentum.
Yes, and you'll like it even better. when you
I
help
read
me
the
drag.
chapter before I did the test, and then when I took the test, I was like, I want to use momentum in all these answers.
Yes.
When it
and
goes
wanted
up, I want
talk
to be
about
like
it
the
all time.
momentum.
Wait, did you read the whole chapter?
No, I mean,
I was about to say.
Okay.
we talked about
I only
momentum.
read the whole book last week.
So, momentum. One of the things that they're going to try to trap you about is momentum a vector or a scalar quantity?
Vector.
Momentum is a vector quantity. Please, please remember, there's a trap on the test. I mean, question on the test
A
about.
trap.
Yes, momentum is a vector quantity. So we've
A
got
trap.
momentum is a lowercase p, which I can't write. New pen.
Gross.
Pull a carrot out of the
Can't make an
thing.
M either. Oh, that's horrible. Okay, momentum is mass times velocity. So its units are the kilogram meter per second, obviously.
Why do they make it a P?
Yeah, I don't know.
Because they
Because
can't have
M
an
is
I mean, I know
mass.
M is mass, and sometimes
They try to mix it
and
up with
sometimes
power.
molar, and
Why didn't they use the Greek
Yeah.
letter for M?
It's probably
They
already
already
used.
have.
Because I can't draw it. That's
For the-
definitely.
Wait.
They should just
Coefficient
write
thing.
momentum out.
Oh, no,
I
was a
kept
nice
getting
job.
yeah, that's me,
confused.
you're right. Well, there'd be an uppercase Greek M, which probably is something else. I don't know what it
Oh,
is.
yeah.
So, mass is scalar, velocity is a vector, so momentum is a vector. In what direction will the momentum vector point?
Wherever the velocity is pointing.
Momentum vector,
Negative.
Negative 1 point.
and
Negative
velocity
Roger.
vector always point in the same direction. Again, one other question on the test about that. Seriously, momentum and velocity point in the same direction. Okay.
Which
Um,
is
So like there can never be a vector going like this way and one going like this way.
If your velocity vector is going this way, your momentum vector is going that way.
Okay, so I have to be parallel.
They have to be,
Okay.
yes. So, momentum, usually if you're going to the right or up, it's positive, but as long as you maintain the same thing throughout a problem, you can decide what direction negative is. What does momentum tell us about?
T equals mv.
Okay, so momentum tells us something about mass and velocity, right?
Yeah.
So,
Oh, okay. So the more massive an object is, the more momentum it will have, and of course, the faster it's going, the more momentum it will have.
yes. One thing it doesn't necessarily do is if you look at momentum as compared to kinetic energy, what's the equation for kinetic energy?
T equals 1/2 mv squared.
Okay, so you can see a similarity. They both have to do with mass and velocity, right? But, and we know that we have conservation of energy, the law of conservation of energy, which says what?
Is that the one energy?
Momentum.
It's energy.
Squared.
Energy can't what?
Be
Oh.
created.
Be created or destroyed.
Only change one.
Is that the right one?
Okay,
Okay.
yes, so that's all conservation of energy. And so in the universe, energy has to remain constant. All the energy that was at the beginning of the universe still is.
That's cool.
Yeah.
Oh,
So if you are talking about on a smaller, less grand scale, in a closed system where no forces, no outside interference is acting in the system, then you also have energy conserved, right? So, just like when we ignored friction, we started with all potential energy at the top of that chute, the ball rolled down and it was all kinetic at the bottom of the chute, and we said that potential energy at the top was equal to kinetic energy at the bottom, because in a closed system, energy is conserved. Now we knew that that wasn't totally true because friction also was affecting the system. It wasn't really a closed system. But we also have a law of conservation of momentum, that if there's no force acting upon a system, that we have momentum also conserved. Now you can see there's a slight complication with that because momentum is conserved with mass times velocity, but energy also has to be conserved in that system, and you've got mass times velocity squared. So that affects the way that things move in the world, because things only move in such a way to conserve both momentum and energy. So we'll see a little more about that next week, but I thought I'd throw it out there because it's interesting and it'll keep your head thinking about that as we go along. So what is the law of conservation of momentum while we're at it? Or did you get that far?
Yeah, it's like if, hang on 1 second. When the sum of the forces working on a system is zero, the total momentum of the system cannot change.
Okay, so basically you have a closed system, nothing, not friction, not air resistance, not gravity, nothing can affect the system, but as long as that's the case, as long as it's a closed system, momentum is always conserved. So we also have impulse. You guys read about impulse too this week, right?
Yes.
Okay, because the egg drop's kind of supposed to be at the end of the chapter and I get nervous, like, did you
Are
read
you gonna do
everything
the
you
egg
need to
drop?
know?
No, it's like.
Yes, today,
Today?
yes.
That's cool.
I'm throwing mine up in the air.
Is it the one where you
Oh,
like try
this
and
is gonna
build
be
something
awesome, I just
to
remembered.
make the
We're gonna
egg
take an
stable
egg.
when you
Isn't
drop
this
it
gonna
from
be awesome?
high things?
Yes, you
That's
have
me.
to.
It's gonna be awesome.
Parents, I mean, my mom did an egg drop today.
Oops,
In her
I did an
No,
oil
in
drop
her
today in
class.
my class.
Oh, I did actually drop an egg. I was trying to get out an egg for my yummy egg breakfast, and then
Yep.
Yeah, I did that when I was
fell
younger.
in the fridge, and that's always the
Oh.
best. And it dripped down into the freezer seal, but I didn't open the freezer, so it stayed.
I hope you
It took
opened the freezer
forever.
after you were done cleaning
Oh,
and
and
gave
then,
it a little.
oh yeah, I wiped
Okay,
it
good.
after. It was nasty.
Yes, not fun,
my
especially
egg
egg
burned.
freezes.
I hate it when I drop things. I was
Well,
like,
I got you
"Whoa,
guys medium
gosh."
eggs this year too, so hopefully they're a little bit sturdier than the large or extra large eggs of the past. We'll have to see.
I was only carrying
But-
one egg too. It's like,
What? No, I never have.
I don't think they're
I
selling.
looked because I was hoping they'd be sturdier the smaller they were. Because they say that an egg can only grow so large, like, you know, ostriches kind of have a maximum size if you do the math of like the surface.
they have huge eggs.
Yeah, but if there couldn't be a bird with much bigger eggs because the shape and the material it's made out of just cannot support.
What about
itself.
dinosaur eggs?
I don't think that they were very much bigger. Like there's a size limit to the shape of an egg. And so like,
What were
What if the materials were different?
if the material
If
was.
you dropped like an ostrich egg.
But I don't know much
No,
about
like
dinosaur
a dinosaur egg. Like,
We don't have dinosaurs though.
I would love
Yeah,
to
we
have
can't get
a.
our
Wouldn't that be
hands
cool
on
if like
any
made an
dinosaurs.
omelet that was like
All
this
right,
big?
poor Sam is listening to this
Dinosaur.
random rabbit trail.
Oh.
So impulse.
Rabbits.
Oh, hi, Sam.
Impulse.
I love you. No.
Okay, so impulse relates momentum and force, kind of. So if you have, well, what is impulse related to momentum? They're very, very similar.
It's like big F equals, no. Oh wait, it's right here.
Impulse equals
Delta
F.
P equals F delta T.
Delta P equals F delta T.
Or F equals delta P over delta T.
Okay.
Yeah, something like that.
Something like that. I need a better marker because poor Sam isn't going to be able
So
to see
P
this.
equals impulse.
Can you read that, Sam?
No,
He
definitely
can't
not.
hear
And I
you.
need to write bigger.
He can hear us, we just can't
So
hear his
if you look at
response.
momentum,
Hey Sam, talk to me. Talk to
so
me.
which part of this equation is impulse?
The
The P.
cool.
So this is force, this
Oh.
is time. The change in momentum is impulse.
Oh,
Yeah.
Jared,
what?
I like eggs.
Why do we always end up like passing the camera around
I don't know.
to
Tiger
personally?
has a
He
tongue.
probably
What
gets
do you
dizzy
do?
watching.
I know.
Ooh,
Sam, the
dude.
change in momentum is impulse. Delta P is impulse.
Delta P.
So, delta
There you
P,
go.
remember.
There's a lot of impulse going on here.
So, when we're dealing with something like an egg drop, then are we going to be able to change the mass of the egg?
Mm-mm.
No,
Oh, what?
all the eggs,
Ooh,
we're
we
assuming,
could poke a
My
hole in a
side.
pin and drain all the stuff out.
we could, but we're not
That
gonna.
takes so long. I tried
Or-
to do it one
or
time because
stick
I
it in
wanted
the
to
water
paint eggs.
and
I
they
was
could
like, this would be
absorb
so cool, so I stuck it.
Interesting thought.
Well,
It wouldn't drain.
Yeah, because it can't. The air can't get in. You gotta
Well,
poke
no,
a
you have
hole
to
in
get
each
rid of the
end,
shell
and
first.
then if that's going too slow, like put a vacuum cleaner on it or
I
something.
had no
Ew,
idea
don't
you had
use your mother's vacuum cleaner
two.
for
Ooh,
that.
you're like sucking
You are
egg.
Yes, two
crazy.
holes, two holes.
Oh,
Always,
I
like,
only
if you're
did
doing
one.
anything
I was
that
like,
would
why isn't it
Well,
drinking?
yeah, 'cause-
Oh,
Especially 'cause it's such a
shaking.
loud-
It needs to get air in and egg out at the same time. They can't do that through one
Yeah.
hole.
Or
I'll
you just
try it
crack it
sometime.
into a bowl and then just take out the
When we
stuff.
drop our egg onto the cement, are we gonna be able to change the force that it experiences?
Yes.
Yes.
Well, depending on how fast we drop it.
Well, it's gonna experience the same force. Okay, I'll just tell you.
Did we
right
learn
now.
about
Because we're
that
just
in
gonna be,
like
like,
a
sitting there.
review question?
Because force is mass times acceleration, right? Now, you're not allowed to change the acceleration. You cannot
Okay.
parachute your egg. Yes.
But if we're dropping it from a different height, then it would experience more acceleration.
It's gonna be
Acceleration
so
is
awesome.
constant, 9.8.
Like it can go faster and faster.
It'll experience a different velocity. So I'm gonna drop all your eggs from the same height.
From on top of your
Okay.
car?
No, Matt took my car. My husband has my car
can-
today, and I have the shortest car ever. It's like this high. I
So
can
we're
reach
gonna
higher
stand
than
on.
that.
Oh, my truck.
So, ooh, do you have a truck?
Yeah, I have my truck.
That
Stand
could
on
work. I was gonna do.
Yes!
You know the steps
Score!
leading up to the trailer out there.
I get to stand on my truck.
No, I get to stand on your truck.
Oh.
Um,
Well, I can do it
Because
later.
it's only fair if I drop your eggs. It's not fair if you drop your eggs, because you'll be like on everyone else's egg.
Oh,
Yeah, I'll
You could
take
change
Matt's
the
egg and just
force.
throw it at the
So here's the
ground.
thing: you could change the force if you caused it to have extra velocity at the beginning, but we're going to say you cannot change the force. All these eggs have the same mass and the same acceleration because each egg, we're assuming, has the same mass as each other egg, and the acceleration due to gravity is 9.8 meters per second squared. So you're not allowed to parachute your egg. So hopefully, ignoring air resistance, which could be a factor, but we're not allowing parachuting. So hopefully, all the eggs will experience the same force because the same mass and the same acceleration.
Question.
Yes.
Does that mean that we're doing something different from the book?
Yes. No, we're not doing 9.1 at all.
Okay.
Oh, we're not?
9 point.
I wrote 9.1, egg drop.
Well,
Yeah, get
right,
it right.
not 9.1 egg drop because it's kind of
Yeah, get
it's
it
in
right.
place of
No.
9.1. So if you call the lab report 9.1.
Well, you called it 9.1 in your little, like, write-up about it for our...
Yeah, and I think there's a parenthesis thing that says not exactly 9.1, but something. So
Yeah.
can we change
Stop eating
delta
carrots.
P? Can we change
Ooh, I
the
love
mass
carrots.
times the velocity?
What was the question? I'm sorry, I was writing.
Okay, we can't change the force. The egg is going to experience the same force
So-
when it hits the concrete. Can we change the momentum?
Yes,
Yeah.
yes, you can, because you can throw it or you can just drop
Well,
it.
but I'm going to drop them all the same from the same height.
You can't. Well, the wind could change
Depending
it.
on,
That
are we
could.
playing something
Or
around
snow
it
could.
to help it?
Yes.
So if we have a heavier, like cushion or whatever it is, like than someone
Okay,
else,
that's
you can have a.
interesting. The more
different
mass you have, the more.
Guess who's
like,
gonna
what
win
if one
today?
egg's heavier than the other? Like,
Okay, so that's something to consider.
Mine
when you're
cracks,
building
I'm
your
gonna
thing. But
shoot myself.
basically, we're gonna have the same mass, same velocity, so we're not gonna be able to really change the momentum, but what can we change?
the time.
We can change the time. If you experience,
Wow.
if you experience a force over a very short time, then you experience a greater impulse. If you experience a force over a really long time, then the impulse is less, so your egg is less likely to break. So what you're trying to do in the egg drop is you're trying to build a case for your egg out of the materials I give you to extend the time over which the egg stops. Yes,
I dibs rubber bands if you have them.
I do.
Are you gonna give us peanut butter?
No.
How about
So-
gravy?
That's
Just
gonna be
think
like
of, like,
sticky.
Gravy when
Well,
it's
no,
egg.
in a
No,
tub. Put the egg in the peanut
That
butter,
was just
drop
the
it,
next
That
and
would be
it's
way too easy.
Gravy wouldn't do
So
anything.
picture your egg, right?
I feel like
Okay.
it might.
So if you drop just the plain egg
Mashed
and it
potatoes.
hits the concrete, how much
Damn.
time is it gonna take to stop?
0.01 seconds.
Nothing. Bam.
How do you know that?
So if you have,
How
say,
you know?
Christina wants to do something with a rubber band, right? So if your egg has some sort of rubber bandy thing and it hits the ground and then the rubber bands allow the egg to keep moving over a longer time, it experiences that same force
It's
over
gonna
the
break.
Hey,
longer
that's
time.
kind of like the rubber band thing.
That's
It's
not-
kind of
Can
like
I
how
have
Nathan,
my egg hard boiled?
No.
It's
all
kind
the
of
eggs
like
are the same.
Nathan Dotson's phone. He has this case and it's got like it's like really shock absorbent and it's kind of like a
Yes.
rubber bandish thing. And he threw it at the ground and it just bounced out
Yep, because that phone is experiencing
Yeah, I
the
have it
force
too,
over
too.
a longer
on
time.
my phone.
Very good idea.
I like to.
To do.
I have it too.
Are we each gonna do one egg?
Yes.
And then are we gonna write up every one?
No, you write your own lab report for your own apparatus.
Wow.
But there is a question about if your egg broke, what you would have done differently based on what you saw from other people's
I'm
eggs,
so
how you would
nervous.
redesign.
This is gonna be so awesome, and I'm gonna
So
win.
far, every year I've had one egg
How much you wanna bet?
survive each year.
Do you know what, has it been the same thing that makes it survive?
Michael did too, and he was the one that survived.
What did he use?
I'm not telling.
Well, but we're both
A
years
phone?
say the same thing that.
Yes,
I'll
the
put my
very
phone case
similar
on top
design
of it.
both years survived.
So if I come up with like a
Oh,
crazy
no.
name
Yay!
and it
I think
survives,
Josh's is gonna survive.
We'll take
Probably.
pictures.
Wait,
I
which
need to
Josh?
take pictures.
That one.
What are you
One
trying to
other
say?
thing I've noticed
you're
is,
stupid.
No.
I'm not gonna say, I'm not giving you any hints.
Alright, let's go do it. Woo.
Hey, I got a better
Well,
test grade
hold on,
on my
let's
last
talk
one.
about some
You
math.
saw, because graded it.
Hey, no bragging.
No, I'm talking about in the other class, not yours.
No, I got
No
a better
bragging
grade.
about that
I
either.
got 96
So,
Oh.
we've talked about conserving
I got
momentum, we've
96.
talked about that, that's next
I mean,
week.
You did that too.
I did good.
I got one wrong.
86, I think.
There's nothing interesting going on here.
7.
Okay, let's talk
Or
about
9.
review questions
That's
and
not
practice
practice
problems and
measurement
then build the thing. So,
Do
no
we
rabbit
need it
tails if you
here?
have less time to build it.
Oh.
Can we change the structure of where we drop it, like the ground, like put some?
No, it's
No,
landing
we
on
changed the
concrete
structure
from a
of
height.
the egg itself.
My truck's
With
pretty
my
tall.
mind.
Yes.
Take it apart.
We used to drop it into the old stairwell,
It's like
like going
okie
down
dokie.
under the
So
old
a full
building.
story.
It was a full
Wait,
story on the
so you're
concrete,
gonna
so
have
you'll
to do
have
it.
less, a
Wait,
little
did you drop it
less.
in like a bucket?
Actually, you're
Like a-
gonna.
like a huge mess.
I have a garbage bag,
Okay.
and one would hope that your little cases or whatever you build would sort of preclude a little mess. I have 2 garbage bags, so we can dispose of everything.
Well, you might actually, you might be able to. Too bad I don't have a ladder in the back of my truck. We used to have a ladder.
You
I'm
put
not
the
good on
ladder
ladders.
on
All right, here we go.
Oh,
So,
Ladders are kind of frightening.
how many
I like
review
ladders.
questions did we do?
7.
7. Number 1, an object's velocity vector points 45 degrees northeast. What is the direction of its momentum vector?
45 degrees northeast.
The same. Velocity and momentum vectors are always the same. They don't have to be the same magnitude, just the same direction. Number 2, which of the following are legitimate units for momentum?
The
The
grand.
second one and the third one.
The second one and the third one. You have to have a mass times a distance divided by a time. No squares on anybody. And normally, what is the unit for momentum?
Oh,
Kilogram times meter over second.
Kilogram
just
meter per second.
bored.
Is that what he called a while?
Yeah.
I think
I
it's a lot
used
that, 'cause it's a lot
it in
easier
one
to-
of my.
I laughed at
miles.
that.
While.
It's a
It's
lot
like-
easier to say while than it is to say kilogram meter per second.
That
Let's
is
call it
true.
the while.
And he
The
wrote the
wild.
book.
it's called the
So.
whoa.
Yes, but he has mistakes in his
Wild.
book. He doesn't deserve
Wow wood.
Everybody makes mistakes.
a unit.
Everybody makes
I don't make
mistakes.
mistakes.
We
I'm
should call it a
serious.
Matthias.
Jesus doesn't
No,
make
I make
mistakes.
mistakes. That's true. So,
Yeah. You got one thing right.
I totally make
I
mistakes
said
all the
Jesus
time.
doesn't make mistakes.
All the time. Number 3,
Jesus.
under what conditions can a compact car have the same momentum as a large heavy car?
If the compact car is going faster. And if
Yes,
you're on the highway,
or
then the compact car is always going to have less momentum because it can't go that fast.
Yeah.
Unless the large car driver is
What do you mean,
going
like a
slowly.
Hummer?
No,
So-
like a smart car.
So that
like,
would
dude,
be
they're gonna get
almost
murdered if they
right.
get
Almost right. What's
wrecked.
wrong with that? If it has to have the same momentum,
Velocity.
its speed has to be larger.
Or smaller for the semi.
Right. Okay, so their speeds have to be. The speed has to
no.
compensate for it being smaller in mass. But what's the other thing to have the same momentum that they have to have? The same. Here's the trick.
Velocity, or
Momentum.
direction.
Direction.
Does it
So
have to be, like,
for them to
wavy?
have the same momentum,
It's in
the
the
smaller
same-
thing has to have the larger speed, and they have to be going in the same direction. They don't have the same momentum if they have an equal magnitude of momentum but a different direction.
So if you have a semi-trailer going down the highway at 1 mile an hour, it would have about the same momentum as a smart car going the same direction at 60 miles an hour.
Assuming that
Holy-
the thing weighed 60 times more.
Wouldn't that make sense?
An 18
If it's
wheeler
if it's loaded with like
Yeah.
stuff.
with like beds.
So here's a good example of impulse
Or
and what you
corn.
guys need to think about for your egg drop. A golf ball
Carrots.
and a lump of soft clay are thrown at a wall. They have the same mass and the same velocity, and they stop when they hit the wall. Which object does the wall exert the most impulse on?
It's the same for both.
Same impulse. Now how do you know?
Wait, no, wouldn't it be the golf ball? Cause the
Golf
clay-
balls are bouncy.
Wait, no.
The
The
time,
No,
clay-
they're the
clay
same. They
does-
weigh the same.
isn't the
The
time
clay
gonna be
would
different
have
though?
different impulse.
No, well, yeah, but that's for situation number 4
Oh, okay.
on question 5.
Mhm.
Yeah,
Alright.
okay.
But no,
Okay, so
they
guys-
weigh the exact
Yes.
same thing.
Okay, this is kind of going backwards, but okay. So say the smart car and the truck had the same momentum. Okay, but it would still be more dangerous to get hit by the smart car, right? Because
No.
it's getting hit like
When you're
No,
in
it's
it.
got
I would
the
be like
same
this.
momentum.
yeah, but you're getting
Assume-
hit in a shorter amount of time.
But when you're in the car.
So like you're experiencing a greater impulse.
What if you're outside of it?
So wouldn't that hurt
Got
you
hit.
more than the
Doesn't matter.
semi-trailer that's going really,
I'd
really
rather get
slow?
hit by a
I'm
smart car
guessing
than
I'd
hit by
rather-
a semi-trailer.
You can
Going 1
jump
mile an
over
hour?
the smart car.
The
No.
smart
Yeah.
car.
That's so confusing.
Yeah.
I think you would total the smart car.
Well, the thing is, I'd rather get hit by the semi at 1 mile an hour than
Yeah,
the
but
smart car
like,
at 60.
what if they both had the same?
Because the semi at 1 mile an hour is going to stop instantaneously. The
different
driver's going to
impulse.
stop.
What?
But then the other one's just gonna
Well,
be
if
like.
he doesn't, then he's going to run me over at 1 mile an hour.
60 miles
Which
an hour.
is not.
And then if you just like
I don't
let
even know
the
those
truck
smart
go
cars
over
can
you.
go
But-
60.
But I'm saying like if they didn't stop and just like the immediate impact,
I
the
don't
smart
think the
car would be
smart
more
cars can
dangerous
go
because
60.
like it'd be
Maybe
I don't
like
think they
30,
can.
60 miles
20,
in an hour versus 1
18.
mile.
Yeah.
Well, I'm guessing that you'd control
It's like when
time
it was, like,
because
old
the
Barbie.
amount of time that the 1 mile an hour semi is going to hit you is going to be a lot less than the amount of time
You're, like,
that the
walking
60 mile
towards
an
it.
hour smart car is going to hit you.
Uh,
So is there something about,
If you're
like-
walking towards the semi.
okay, like why does a
Ow.
batter follow through? Like your swing, you hit the ball, why don't you just stop as soon as you make contact with the ball?
because the time increases the momentum and velocity or impulse. Something
Because
like
the
that.
your swing
Yeah.
is so fast you can't stop it.
I'm not, but you know, maybe you
When I was younger and played baseball,
You're always talking.
my
about
dad
it.
used. My dad used to always tell me not to stop because I would always stop.
If
And
you
he was like-
stop,
Same with kicking a soccer ball.
Yeah.
Yeah, it's like-
right. The longer your
We're
foot
throwing
is
a
in
football.
contact with the ball, the longer
Yeah, throw a
the
football,
bat
you're
is in
just like-
contact with the ball,
Shot put.
then the more you are able to
Yeah, but blue shot puts
increase the force that you're doing because it's over the time.
spin around.
So you're gonna, want to continue on through so that you're contacting that ball as long as possible. My swing is undoubtedly embarrassing,
Mine's awesome.
but
I don't think I could actually hit the ball.
I can hit the ball.
Never
if
played
it's-
baseball
My
before?
shoulder's too bad these days,
How
but
about
we gotta
softball?
keep going. Here we go.
Wolf
Okay,
ball.
so
Yeah, with
the
the ball.
Play
impulse is
T-ball,
gonna be the
But not on
same.
a team, just like that.
Because impulse is delta P, so change in mass times change in velocity. And they have the same mass, the same change in velocity from the same velocity to 0. So they're gonna have the same impulse. They're trying to trick you on that one, so pay attention. But if you look at number 4, on which object does the wall exert the most force?
You mean 5?
Force. So if we have the same this, right? Which one's gonna take more time to stop?
The golf ball.
No,
the clay.
The clay. Because the golf
'Cause
ball's
it'll
like bam, stop, and the clay's like mwah, and that takes some time. Do I have to
Well, yeah,
repeat
but
that?
like the
Oh,
force is
kinda
gonna
like-
be really strong on the.
Kind of like if you had a
Golf
golf ball and a tennis ball, the tennis ball is gonna like
Squish.
form to it and squish, and then the golf ball is just gonna be like.
Alright, so if we're able
If
to,
it was a
to
ping pong
increase
ball.
the
If
time
it's a
over which
paintball.
we stop and we hold this constant, then what are we doing?
What?
Decreasing
If you
force.
get shot
Decreasing
and
force.
it's hard enough, it would bounce.
So,
That's
I wonder if then you are decreasing force when you drop your egg. Maybe I'm wrong.
Wait.
I'm really distractible. Would we be decreasing force on our egg if we increase the time over which it experiences the impulse? I guess maybe we are.
Yes, because.
Alright, Sam, everything I said at the beginning of class is wrong. You can decrease the force by increasing the time.
So I was right.
Everything I said was right though. I'm
What, like if you make it fall slower?
Well, we're not gonna make it, we're
if you-
trying
Well,
to not parachute the egg, to keep.
Oh, like the time it takes for it to stop.
Right, as
So
the
like
egg
what-
Make a
hits.
base on it.
So,
That's
like-
I wish I had some silly putty. So the egg
affected by
hits,
air resistance.
if it experiences it over less time, it's going to, maybe I'll just cut the front of that video off and let no one see it.
Because you got Josh saying some weird stuff.
So we'll have, a quick time is gonna increase force because the impulse is gonna be constant. And a slow time, so if your egg is like rubber banded, so when your apparatus hits the ground, if your egg can still keep moving a little bit, it'll experience less force because
What
it's
supplies
experiencing
are
the
we gonna
impulse over more
have?
time.
Right.
Ah, that is the question, isn't it?
When,
I
when are we
changed
gonna
it.
do it
Paper, one
soon? Like
pencil,
5
one
minutes
rubber
from now?
band.
10?
No pencils, but skewers.
What?
What's a
skewers.
You
skewer?
can.
No poking. This is a non-poking zone.
We have to keep the masses.
Alright,
Maybe we
so the
spit
golf
on
ball's
it,
gonna
it'll
stop
get a
faster,
little-
the wall has to exert more force to stop it. Number 6, a cat and mouse are running with equal kinetic energy. So here we are with equal kinetic energy. Do they necessarily have the same momentum?
No,
Wait.
No, why not?
because they don't have the
Because
same
cat,
mass,
the
probably.
mouse is smaller.
Okay, but if they have equal
Probably
kinetic
not.
energy,
The mouse.
then
It's like
one half
it's-
energy
It could
are
squared
they the
will
same
say
mass?
Big
It's-
mouse.
It could be a little kitten,
A
okay?
big mouse.
And
It's
they're
like
really
a big
One
rat.
of those
So-
big rats,
so-
yeah.
You don't know if their
Big.
masses are equal, you don't know if their velocities are equal, but if they have equal kinetic energy, they don't necessarily have equal momentum. Now, there are 2 times in which they would have equal momentum,
They could be running in different directions.
Is that what they're, yeah, they're.
Okay, if they're not going
momentum
exactly the same direction, they
conservation.
always have different
What if the
momentum.
cat's running
But
slower
if you
than
look
the
at
mouse?
momentum and kinetic energy together, what one thing could what would make this true? Oh, where's my red pen?
Just
It's
don't use
on
blue
the other
markers.
side of the.
I've got nothing.
It's by the
It's,
chemistry
it's,
book.
it's right there.
Like,
By, by you go.
Thank you. Okay, so
Sam's
if we
like,
look,
it's right there.
when, okay, when would this be true?
When
We
mass
know-
is big because velocity is squared, so. Wait,
Okay.
no,
This is
No.
the same animal.
When
the
velocity
mass
equals
on the
0?
right is big.
When mass
No.
equals velocity?
I don't know what
The
to
mass
say.
on the right is big
I don't know
because,
why.
the velocity
Okay,
on the
so
right
if
is
it
smaller.
was
So,
2, and if
if
it
velocity
was
is smaller,
half
mass has to be bigger.
then if it was half of that.
What if the
it's
velocity is
1.
So
I
let's
don't know,
say,
I'm confused.
If
What if you have the
both of
velocity
them
bigger
equaled
too, like
1.
V1, V2.
we could
No, that
say,
wouldn't work.
let's say the cat equals,
It doesn't work.
I don't know, 10 pounds, and the mouse equals
2
5
ounces.
pounds.
That's a
Right.
fat mouse.
Yeah, it's a capybara or something, whatever, some sort of
Capybara's
rodent.
bigger.
But it'll be maybe easier to do the math. So if we have 1/2,
1/2 of a cat.
let's see. Ew, yuck. I don't
Half
even
a
want to say
cat.
that, half a cat. So let's talk
This is
about
good. It's like
Chinese
momentum. Our cat's momentum would be 10 pounds times its velocity. The mouse's momentum would be 5 pounds times the velocity, right? So what would velocity have to be? Because it's not equal, right?
For the cat, it would be 10 and the mouse is 5. No, switch that. The mouse is 10 and the cat's 5.
Okay, so is there anything we can do
Sounds so
that would
weird.
make the kinetic energy
cat.
the same at those weights?
I don't know.
Let me think.
Sorry.
Probably there's something you could do. Like, if they weren't moving.
Well, the measure energy.
But it says.
Yeah, but then-
Auxiliary.
If velocity was 0, it still wouldn't be equal because that'd be half the mass equals mass.
Right, so that'd be bad. There probably is some way that we could use velocity squared to get an answer.
Wow.
But if their mass is,
Yes, because 1/2 mv squared gives you
Well,
your
we have
energy.
to like do the whole math to see what the
Right.
answer is for it.
Like,
alright, so,
I'm confused.
Too many
yeah,
cats.
I love doing
Or
that.
math,
cat.
the math would have to be really big.
The mouse already is really big.
Yeah, the mass.
The mass.
Okay, what
Oh,
if
okay.
mass and velocity were both 2?
If mass and velocity are both 2,
Not together, just like mass
so
is
they
2.
have to have the same mass is what you're telling me.
Yeah.
Well, then you have
Okay,
to have a
so-
tiny kitten and a big mouse.
Okay,
like-
tiny kitten and a huge sewer
That would
rat.
just be 5 equals
It'd be
4.
one of those rats
No,
from
So
like
if mass
it
is
they're,
2
wouldn't.
for both of them.
almost
5
like 10
equals
pounds.
4, Christina, that doesn't work.
No,
It's
it's
10-pound
2
rat.
times
If
2
velocity
equals
were
4, and then 2 squared is 4 times 2 equals 8 divided by 2 is 4.
No,
Say it again, say it
no, Christina, half of
How do
2
you get it?
is 1.
Isn't it supposed
And
to
then
be mass,
one-
not
No,
weight,
Andrea.
anyways?
Oh, but then it'd be 1 times 4, so then
Because-
it'd be 4 equals
yeah.
4.
2
Yeah, in your
kilograms.
face.
No, because the 1/2 is for everything. So it's 1 times 4 times 1/2, which is
Yeah.
2 equals 4.
No, it's not. You guys.
2. We know 2 isn't 4.
Okay, so if I have my mass here times my velocity here, it still wouldn't work. Because at least the 1 squared.
2 times 1 is 2.
I have these little epiphanies all the time. I do all these complicated equations. I'm like, yes, I got it. Wait, no, that
It
doesn't work.
Yeah. Okay, so we're not coming up with any real easy
Where's my
answer to
pencil?
when kinetic energy and momentum are the same.
Where's my
Now,
pencil?
I will tell you that I'm going to answer this question a little better next week.
Ooh, maybe it's some
Ooh.
sort of
I
weird.
But the answer's just no, so it
like
doesn't matter.
It's some
Right.
weird
7/10.
comparison
No.
thing, like 1 joule equals 2 joules.
No.
No,
It's
2
not
joules
ever.
equals 8 joules.
Okay, so
Okay, look.
No.
Look at this math.
kinetic energy and momentum
Damn.
are not usually equal.
I think you're right.
Aha.
I don't think I'm right at all.
1/2 mv squared.
Bumbo.
Where's your squared v?
I already squared it. 2 squared is
Okay.
4.
And then, but what about
D for
2 mass times velocity? What's your velocity?
2.
1
2 times 2 is 4.
No, me and him
Okay,
both
so
came up with it. That is
Christina's got one moment that might work. So what's mass in that?
Oh yeah, because if mass is 2 times 4 is 8 times 1/2 is 4.
Yes.
Okay, so what's our mass where it works?
I feel like I've defied physics. This is awesome.
What's our mass?
2.
And what's our velocity?
2.
4.
2.
No.
Okay,
two
so,
where?
I was
Where's
thinking
square?
2 plus 2 is 4. So, sorry.
so if we have a kitten and a rat that are both 2 kilograms, and they're both going exactly 2 meters per second, then kinetic energy and momentum are equal.
And when will that situation ever happen?
Never.
And they have to be going the same direction.
Yes.
And the same speed.
And the same
But one-
velocity.
one-
And
Do
the
you
same
see
change in
this,
weight.
Sam?
That has to be 2 kilograms along with the mouse. It was also
That-
2
2
kilograms.
How much is a
Is
kilogram?
genius.
A kilogram is
2.2
2.2
pounds.
pounds.
Like, well,
So we got a
that's
5
small cat.
kilogram rat. Yuck. Anyhow.
Make steaks with that thing.
Under what conditions is momentum conserved? So what's the law of conservation of
rats.
momentum, basically?
Couldn't
When
that work
all
with
the
any
forces
square
in the
root then?
system are equal to 0.
Yes, maybe.
Couldn't that work with any square
When
root
all
then?
the forces in the system are equal to 0.
Momentum is conserved when all the forces are 0 acting upon the
Hold on.
system. So that's good. All right, so here are your materials. You can pick 3. You only get to pick 3 of
Mine's
the
gonna break.
choices. So you
So
can
how do we
pick
figure out
from
who gets picked first?
Can we use paper?
Oldest.
Just
Hopefully I
our own
have
paper.
enough.
What did I like lose
Ow,
or
my
something?
toe really
I'm the
hurts.
oldest, so I get to pick
I
Right.
have
first.
limits
Oh,
on
yeah,
how
you're
much
older
of
than
each
you.
thing you can use. So
You
let me
just
look at
turned
my
16.
sheet and I will tell you how
And
much
you
you
still
can
don't have
use.
your license.
What's number?
Wait a minute, raise your hand if you can legally drive.
Nobody's
without
driving
adult.
anything anywhere. Except y'all might have to, can everybody ride a bike?
Yeah.
Yes.
A
There
bike?
comes a point when, last year we used a scooter, but
I fell off my bike a couple of weeks ago.
Actually, I don't know.
Chain
how to
popped
ride
off
my
and
bike.
it's so scary.
I busted.
Okay,
Oh,
so
the
you
beach
can
cruiser?
use.
Wait, what are you talking about bikes
I
for?
still have that left.
You can use a group of
That's all I have
6
left. It was like
skewers.
4 weeks ago.
I need to write this on the board.
I
Landed on my hip too.
Are you allowed to break
to
them?
Christina's house
Yep.
multiple times.
How far is
Okay,
it?
so 6
Like 2
skewers.
miles.
No, not that far.
17.5 miles.
Just to go to my friend's house and say
Actually, it's
hi.
probably like
Wait,
3.5.
Can you make that face again, please?
6 skewers.
2.5 miles. I don't know when crazy. No. It was super funny.
I'm camera shy like
12
Sadie.
inches of tape.
Stop yourself.
Hey, what's going on over there? You're gonna make Sam
3
puke.
tissues. 4 pipe cleaners. That's a 4.
Oh, hey guys.
We can make some sort of like spider droid thing, like from Star Wars, and it lands on the
Famous
right.
moment of
Every person can pick 3.
doing-
Are we allowed to
opportunities.
break this skewers?
I was like,
So I can get.
Yes,
get
you
6
can break
skewers.
or cut anything.
oh my gosh.
Wait, we have to use only one combination of that.
You get 3 of these items. So you could get 6 skewers, 4 rubber bands, and 12 inches of tape. Or you could get 12 inches of tape, 2 sheets of paper, and 3 tissues. Or you could get, any combination.
I'd like 4 pipe cleaners, 4 rubber bands,
Hey.
and 6 skewers.
This has to be
You
attached to it, right?
disgust.
The egg
Actually,
has to be somehow protected by these things, but not parachuted by them.
I'd like 4 pipe cleaners.
You want to spread the amount of time over which the egg stops.
But what if our
Okay.
design is like a parachute almost? Not like
It's almost
like
what?
if it's like on the base of it and you're using paper and stuff, isn't that gonna give it a lot of air
It
resistance?
might give it some. You can't build a parachute.
So,
but
I don't
yes, the paper will probably.
Wait,
So
is
grab
that,
your stuff.
Oh, thanks for taking first picks.
There's
the
not
green
enough
one
for
is pink.
everybody to get whatever they want.
What color pipe cleaners?
Take the pink
Very
ones
pink.
because no one wants them.
The pink ones are the
Actually,
strongest.
yeah.
The green are mine.
The green or yours? Okay, well, maybe
I don't know if I'm
I
gonna use them
actually
yet.
want a pink one.
4 pipe
Yeah.
cleaners.
Alright, so
I'm gonna go with some pipe cleaners.
I'm going to turn it off so Sam doesn't
Do we have to
watch
use
this
every single
insanity.
thing?
No, you can only use 3 of them. There's
Wait,
Sam, that's what you
No,
can
I mean,
use.
like every.
Where's the
Oh,
sheet
so you can only.
Tell Emily
pick
not to be too
3
sad
of
that
all
she
the
didn't get any
supplies?
pipe cleaners.
So 3 of the